Sakari, Kuikka.
Yeah.
Please.
Thank you, Chairperson. My title is New Challenges in Development of Probabilistic Modeling in Fisheries. This is a joint talk together with Samu. The outline is following. I will start first by discussing a little bit why we need uncertainty analysis, and then I thought to explain a little bit what kind of project ECOKNOWS was. There has been several papers about that, but not really looking at the bigger picture. Then I will continue to the state of art in socioeconomic and actually biological, economic and socioeconomic modeling, and then something about the future. This is basically one of the problems in fisheries science, that we try to predict when the stock collapses. You don't really want to see that data ever, because that's why you are doing the analysis, to avoid that. So there is always a subjective element in the sense that how you look at the stock collapse possibility and what kind of distributions you use and so on. So you cannot avoid that. This is a joke which I always like. And let's say we have been discussing quite a bit different sources of uncertainty. Implementation is one which is discussed but not that much applied to the models. So let's say if we think that we have two management options, we know approximately what is the required biomass. With point estimate model, you would get that A is about 20 units bigger than B. But once you start to look at the probabilities, you may end up that the one with the expected value, which is less than the other one, is actually favored, because the tail probability is smaller. I have a view that this kind of uncertainties are actually quite common if you start to think that this is DAC policy, for example, and then you have closed area or effort control or whatsoever. So it may be that your implementation uncertainty is so high that it actually dominates the problem. We divide the uncertainties to natural variability. Then we have a model uncertainty, model selection. If there are several alternatives, we should model them all. And then parameter uncertainty is the one which is usually mostly discussed, and then implementation. So graphically, you can think that there are slices of CV which you need to model. In practice, it looks like this. Then some words about the ECOKNOWS project. It was funded by the EU 7th Framework Program. The total budget was a bit less than 4 million. The required amount from EU Commission was 3 million. We are soon going to be in the end of the project. We didn't get actually any extension to that. I warn you, everyone, that Commission has nowadays different policy than it used to be. They don't want to give extensions anymore. We had 13 partners from 10 countries, 8 EU member states, and Philippines and Canada were the most faraway countries. Our objective is to improve the use of the ecosystem and biological knowledge in the fisheries science, improve the link between the traditional fish biology. Usually people are interested either about the biology or about the stock assessment, but they are not usually linked together that well. We try to do that. And then we develop methodology by which we can use the big data sets, databases. FishBase was one of them. We had a paper here by Rudy the first day. And then one aim was to improve the ways to find understandable biological reference points. Okay, then I will go to the state-of-the-art section. There are some examples together what we found with Samu about the contents of the different packages. Casal has a lot of biological and fishery functions, but it has a limited process error modeling. Only recruitment has random effects. Coleraine, more options for process errors, recruitment and selectivity, but it has only age structure, not the length distributions, and no uncertainty about the process errors. Stock synthesis is flexible in the sense of the description of the population structure. There are more options for the process errors. And the negative side is that random effects and environmental covariates cannot be combined and no model uncertainty. One of the usual problems, this came to my mind when discussing and listening to the talks here, that often technical problems dominate. If you have problems in the convergence of the MCMC values, you easily start to assume that some of the estimates are known precisely. Actually, we often fix the parameters and then get an artificial increase in the uncertainty to get some results. And in the end, we have some kind of reasonable CV estimate. In the technical problems, if there is no convergence, information contained in data is not really taken into account. And then I have a couple of messages from how I see the economic information, economic assessment tools. There are quite a lot of individual papers, but very few Bayesian papers, actually. When you look at the literature, so you don't really find too many Bayesian papers for some reason, even though you could consider that the economic variables are especially of interest to the fisheries people. And the economic risk is the dominating one. Commonly used assessment softwares are to a large extent missing. There is no similar widely used packages like in the case of the biological fisheries modeling. There are no large and easily available data banks. Now EU Commission has been collecting economic information, but that's not really easily available for scientists. And then social modeling, which is close to my heart. Always we are managing people, not fisheries or not fish stocks. There are actually no common theory to my mind. There are some individual papers which describe part of the social dynamics, but not really something common which could be applied in several cases. Perhaps that is the nature of the social information. Atso already showed this. He stole my idea, I think. But you could think of the publication practices and the way how we learn in Bayesian analysis, that you, little by little, you get more information, and then in the end you are more certain about the results. But I think this would actually require some changes to the publication practices, in the sense that you need to report the variance covariance structures, and you need to somehow describe what you have got in, perhaps in terms of discrete probabilities, but in any way somehow be able to describe your results so that other people can really utilize them. There are some challenges in this kind of learning chains. The published papers are not necessarily unbiased samples of the assessment carried out. So usually people publish papers where the p-value is small enough to be statistically significant. And like I said, the publication practices do not favor at the moment the use of the other papers in the analysis. Meta-analysis is needed in a case that there are priors where it's technically possible to learn from the previous papers. Perhaps we should have this journal of negative results in the sense that if we want to unbiased sample from the previous assessments, we should see all the papers, all the assessments done. Thanks for the audience. We need more happy fishermen, I think.